Researchers collected data on the numbers of hospital admissions resulting from motor vehicle crashes, and results are given below for Fridays on the 6th of a month and Fridays on the following 13th of the same month. Use a 0.05 significance level to test the claim that when the 13th day of a month falls on a Friday, the numbers of hospital admissions from motor vehicle crashes are not affected. So we have this data set here, and we can open this up in StatCrunch. And we'll use this here in a minute. What we have to do is decide what kind of a test we have here and what our hypotheses should look like. Now, this notation, mean of the differences, then means that we're going to find the differences between these values because they are corresponding months. So in other words, we've got 9 on the 6th of a month, and then on that very next week, so the same month, we've got 13. And then 5 on the 6th of a month, that's a Friday, and then on that very next Friday, 11. So these are paired. And the way this works is we find the differences and then find the mean of those differences. So when we select this, it should be mean of the differences, not difference of the means. Now, the question then becomes, well, is this a one or two-tailed test? And we note that when the question was asked, the form in which it was asked was, test the claim that when the 13th day of a month falls on a Friday, the numbers of hospital admissions from motor vehicle crashes are not affected. Not affected. So, more crashes on the 13th or less crashes on the 13th would indicate an effect. So we have a two-tailed test, whether the difference is significantly positive or significantly negative, the mean of those differences. That would indicate a difference. So let's look at what this looks like. This can be oriented whether we do the 6th minus the 13th or the 13th minus the 6th. It doesn't matter. But if we were to find these differences with this orientation, we'd have 6 minus 13, so minus 7, 9 or 5 minus 11, so minus 6, and on out. We could continue this out. So we'll get this list of differences here and then find the mean of those differences. We're testing actually the population mean of those differences. And the way we're testing this then is by saying that the population mean of those differences is 0, or the population mean of those differences is not 0. So this would be a two-tailed test. And we're testing this at a 0.05 level of significance. So each tail then would have 0.025. So we would need to come up with some critical t-values. We'd have a positive and a negative. Now we have 6 pairs of data, so there are 5 degrees of freedom. So we would open StatCrunch. We'd push Stat, Calculators, T. We have 5 degrees of freedom, and we want 0.025 in each tail. We can make this less than or greater than, it doesn't matter. We're going to come up with this number, 2.571, when we go to 3 decimal places. So these critical values then will be 2.571 and minus 2.571. And then what we would do is, if our t-test value is bigger than 2.571, or if that t-test value was less than minus 2.571, we would reject the null hypothesis in favor of the alternative hypothesis. So we need to come up with a test value, and we can do that in StatCrunch. We'll click Stat, T-stats, Paired. These are paired data values. We chose to do the 6th minus the 13th, so that's the way we'll select them. Sample 1 in the Friday the 6th, sample 2 Friday the 13th. Hypothesis test is given here, mu sub d equal to 0, mu sub d not equal to 0. We'll click compute, and we're going to get a t-statistic of minus 2.976 when we round to 3 decimal places. So our t-statistic, or t-test value, is minus 2.976. Now, we said that if it was less than minus 2.571, we would reject the null hypothesis, and we see that it is. So we are going to reject the null hypothesis. So we've found that the test statistic was minus 2.976. We found that the critical values were plus or minus 2.571. And since that minus 2.976 value is less than minus 2.571, we're going to reject the null hypothesis. So we would choose D here. There is sufficient evidence to warrant rejection of the claim of no effect. Hospital admissions appear to be affected.